Okay, I'm here at the Royal Aeronautical Society in London, and we are privileged to have NASA Administrator Jim Bridenstine with us. Real honour to have you, sir.
It's good to be here, thank you.
You've been attending the Farnborough Air Show this week. Can you say why you were here and how it went?
Yeah, a lot of really amazing people that I met, but the heads of the various space agencies within Europe, of course, are there, as well as the head of the European Space Agency. So getting to know my counterparts at other space agencies is critical important. And we're building a next generation exploration campaign that's going to include a return to the moon. And of course, with the return to the moon, we want to take with us all of our international partners. So we're building critical infrastructure around the moon. We're going to build what's called the gateway. Think of a space station around the moon. That critical infrastructure is going to be capable of taking humans. It's in essence a human habitation module, along with power and propulsion and logistics and other things. But ultimately, that module is going to be open architecture, so that our international partners can build landers if they want to build landers and go back and forth from lunar orbit down to the surface of the moon. And the idea is to get to more parts of the moon than we've ever been before. And the United States, we can't do this alone. We need all of our international partners to join us in this very big mission. And ultimately, in order to make it sustainable, remember Apollo was a tremendous mission, but when it was over, it was over.
Yeah.
We want a sustainable mission. So we need all the parts of the architecture to be reusable. Not just launch, which, in the United States, we have a number of companies that are advancing reusable rockets. We want the entire architecture to be reusable. So the landers would be reusable, the tugs from low Earth orbit all the way up to lunar orbit would be reusable. And then all of the architecture that's reusable, of course, for sustainability, all of that architecture could feed forward for Mars. So the same architecture could be applied to Mars. So the first gateway, which is a lunar orbiter, would enable us to have more access to more parts of the moon than ever before. The second gateway would do the same thing and give us an opportunity to fly into deep space and even to Mars. So that's the architecture we're trying to put together, and we want all of our international partners to join us, and that's why we're here at Farnborough meeting with all the heads of the different space agencies.
Okay. Why not just go to Mars direct? Why not just that's the goal, head there?
So there's a lot of reasons to not go to Mars direct. When you think about what it takes to get a human from Earth to Mars, we're talking about a 6-month journey. We know that when you're on that 6-month journey, humans lose 1 to 3% of their bone mass every month. We know that their hearts become deconditioned, which of course causes problems once you get put into a gravity environment again. And we know that it's not just your neurovestibular system has challenges when you go from 0G to a gravity environment. And when you go to Mars, you're going to be there for at least 2 years before you can come home. By the time the Earth and Mars line up again for a journey home, you're talking about a 3-year trip. You don't want to take all of these risks for the first time on your way to Mars. What the moon provides us is an opportunity to prove out not just the technology, but the capabilities to mitigate some of the physiological challenges and to learn how to do in situ resource utilization. How do we utilize the resources of the moon? In other words, the hundreds of billions of tons of water ice that are on the moon. Water is very simply hydrogen and oxygen. And when water is split into hydrogen and oxygen and put into cryogenic form, that's the same propulsion that powered the space shuttle, for example. So water not only represents life support for drinking and also oxygen for breathing, but it also represents power and even propulsion. So there's a lot of opportunity to learn what we need to learn at the moon so that we can take that technology to Mars. But the moon is the best proving ground for eventually going to Mars.
Okay. And obviously that's going to need big rockets, and Space Launch System is one of them, but that is consuming a great deal of NASA resources. There's only 2 really funded missions at the moment. What happens after that? Are you worried that this is the rocket that will eat NASA?
Not exactly. So The Space Launch System, of course, is a critical piece of the architecture to get to the moon and onto Mars. It's not only the heaviest lift rocket that's ever been built, it's the largest rocket that's ever been built. It will be taller than the Statue of Liberty, and it will have not just a payload capacity, but a fairing large enough to take large volumes into space. And all of that's going to be necessary to build the architecture we need to build around the moon. Now, that is a national capability that right now we are getting very close on being ready to test and then launch. And we want to see our commercial partners that are also building rockets be successful as well. Again, if we're going to be successful with this architecture, we want to take our international partners with us, and we want to take advantage of the great commercial companies that are building rockets and capabilities that we can use as a service.
Yeah.
In other words, NASA wouldn't own and operate those rockets, but we would use them as a service.
I mean, how do you the commercialization of space is obviously one sort of theme. Can private industry ever provide that kind of long-term investment that exploration of the moon or going to Mars that government or international partners can come up with?
Absolutely. So they're great partners. We want them to be successful. And so when you think about things that are routine, when you think about low Earth orbit, communication satellites in low Earth orbit, which are all the rage right now with constellations of thousands of communication satellites going into low Earth orbit with high throughput and low latency, so you can, in essence, use your cell phone anywhere in the world without any challenges. That's a big piece of future commercial launch requirements. And when you think about remote sensing and imaging, there's another commercial capability there. When you think about deep space exploration, NASA would love to use some of those capabilities to put cargo on the surface of the moon, maybe down the road, or put even cargo on Mars. So there's a lot of opportunity for those commercial partners to do those kind of activities. But again, when you think about what commercial is when NASA is a customer of a service.
Yeah.
NASA isn't purchasing, owning, and operating its own rockets. NASA is a customer. So in some cases where there is no market and NASA is the sole, kind of driver of the enterprise, then NASA will need to purchase and own its own rockets or its own capabilities. But if there's a commercial market where we can just buy something as a service, then we want to do that too. Again, whatever is the most cost effective at getting the job done is what we want.
Okay. Moving from commercial to sort of political, I mean, one thing that powered the race to the moon, 50 years ago next year, was the ideological conflict between the US and the Soviet Union. Do you think that could perhaps return? I mean, if, for example, if China suddenly just said we're going to Mars, do you think that could spark off a new space race?
I don't think so. I think we are two countries with our own scientific objectives and goals, probably going to the same destination. Now, I know they have their sights focused on the moon right now, as do we. And we've landed on Mars now 7 times, and we have InSight going to Mars right now, which will land in November on the surface of Mars. I would say I don't see it so much as a competition right now. I see it as two countries heading the same direction and probably will end up at the same place. But certainly we want them to be successful as we are successful.
Okay. Talk about sort of cooperation. I mean, one of the most successful space programs has been the ISS, which the US is seeking to end funding in 2024. I mean, is this the right decision? Do you think that can the private sector actually take over that? What's basically a very basic research outpost?
Oh, that's a wonderful question. So we do believe that in the next 7 years, the president's budget request said that he would like to end direct funding for the ISS starting in 2025. So that gives us 7 years to come up with a market that could sustain the International Space Station apart from direct government funding. What does that look like? It could be a number of things. Right now they are working on printing in 3D human organs, if you can imagine that, which will be an absolute game changer, because what you can do in a microgravity environment or a zero gravity environment is really phenomenal compared to what you can do in a gravity environment when it comes to creating, biological 3D printing capabilities. So that's number one. That could be a massive market. When you talk about medicines specifically, the medical industry is very interested in what they can produce in a microgravity environment. And manufacturing, of course, is a big piece right now as well. We're talking about especially fiber optics has a big potential in a microgravity environment. So we believe that those markets are going to develop in the next 7 years and close the business case for the International Space Station to ultimately be operated by an international consortium of private companies. The idea being that NASA can use its money and our international partners can use their money to go further. We've been in low Earth orbit now for 20 years, and we're with humans. It's important to note, and I want to be really clear on this, we don't want any gap in low Earth orbit. So we need commercial industry to pick up where we leave off. And that could be a consortium to take over the International Space Station. It could also be other private space stations, commercially owned, where NASA is a customer. NASA is, I want to be clear, we're going to be in low Earth orbit. But we want to be one customer of many customers in low Earth orbit. So commercial can take over, and then we can use our resources to do deep space exploration and other scientific missions that commercial won't do. So I do think that this is the right time to start the discussion, and it'd be very fascinating to see what proposals come back. NASA has requested proposals from industry for how we would commercialize low Earth orbit.
Excellent. Okay. What do you think the biggest breakthrough will be for spaceflight in the next 10 or 20 years? I mean, you've talked about sort of there being fuel on, water on the moon, fully reusable rockets, in-orbit manufacturing, mining the moon or asteroids even.
Certainly, mining the moon and asteroids is on the horizon. There are a number of private companies in the United States and elsewhere that are interested in that activity. Some of the biggest breakthroughs I think that we're going to see, though, are going to be in the realm of propulsion. Ultimately, we're working on scaling up solar electric propulsion for Gateway, which is going to be a tremendous capability for a whole host of reasons, including going to Mars. But we also need to figure out how to live in a high radiation environment for long periods of time. So technologies are going to be developed around that as well. But certainly when it comes to mining the moon and mining asteroids, as you mentioned, we encourage private companies that are interested in that to do that. When you think about why people came to America to begin with, it was seeking commerce. And when they spread across America to the west, it was driven initially by the gold rush. Yeah. And so if there are resources, precious metals, platinum group metals in space, as there is on Earth, which we know that there is, and when I say platinum group metals, we're talking about rare earth metals, which are not earth metals at all. Those are metals from deep space, asteroids that impacted with the Earth a long time ago, and the moon is riddled with such asteroids itself. So I believe there could be an opportunity there to discover rare earth metals, and that would drive commerce to the moon and drive commerce into deep space to see what's available on asteroids.
Okay. Bit of an odd question, but the idea of a space force, separate Army, Navy, and Air Force as headlines this year. I mean, NASA is obviously a civilian agency, but do you think the US needs a space force when it has yourselves and the Air Force, already doing the job?
I think so, and I'll tell you why. Space has become very contested. It's obviously very congested with space debris and other things. But now it's also exceptionally contested. We used to operate in space as though it were a sanctuary. It is no longer a sanctuary. There are proliferating technologies to include direct ascent anti-satellite missiles, co-orbital anti-satellite satellites, jamming, spoofing, dazzling, which is using laser energy to confuse a satellite or even destroy a satellite, hacking. These kind of technologies are proliferating to the point where they're just available to everybody around the world for some of them. So we need to get really good at attributing what the threats are to our space capabilities and ultimately preventing those threats from undermining our ability to operate in space. Now, the reality is we have a lot of capabilities inside the United States Air Force. And it's also important to note, as a member, I used to be a member of the House of Representatives in the United States, and I'll be very clear, I have voted for a separate Space Force on 3 separate occasions as a member of the House. Now, we called it a Space Corps, not the Space Force, but the Space Corps would operate as the Marine Corps does with the United States Navy. It's a separate force, but it reports to the Secretary of the Navy. The Space Corps would have been a separate force reporting to the Secretary of the Air Force. That's not, I don't think, what President Trump has announced. He wants a separate force, equal in stature to the Air Force, which means it would have probably its own service secretary. But what the President did is he looked at the same intelligence that we looked at in the House of Representatives, and he made a determination to go this direction, the same as the House of Representatives did. You know, when I voted for it 3 times in the House, every time it passed with overwhelmingly, bipartisan support. And so this is a very serious policy proposal. Space being a critical domain, it's now important for us to understand that it needs a separate cadre of professionals that are trained to protect it, and report to their own service secretary, and have somebody, a 4-star general that serves, or an admiral, depending on how they want to organize the rank structure, that sits on the Joint Chiefs of Staff, which directly advises the President on national security issues.
Okay.
Tim, we've got to get downstairs.
Okay, all right, so have we got time for one more?
Sure.
Okay, final question, I suppose, a little bit of a fun question. Favorite fictional spaceship?
Oh, my favorite fictional spaceship. Oh my goodness, there's so many good ones. I would have to go with an X-wing fighter.
Excellent.
All right.
Thank you very much.
Thank you.
That's been brilliant.
All right.